The secrets of time. Why can't we travel to the past? Imagine this. You have a time machine. Would you go back to fix a mistake or leap forward to see your future? The idea has fascinated us for centuries, from ancient myths to modern sci-fi. But what does science say? Today on Curio², we explore one of the universe's greatest mysteries, time, and the big question, why can't we travel to the past? What is time really? Everyone experiences it, but few can define it. Is it a flowing river? An illusion? Just a number on a clock? To Isaac Newton, time was absolute, a constant universal rhythm that ticked the same everywhere. But then came Albert Einstein, and he changed everything. With his theory of relativity, Einstein showed that time is not absolute, it's relative. It depends on speed and gravity. The faster you move, the slower time passes for you. That's not sci-fi, it's proven science. A famous experiment flew atomic clocks on planes. When they returned, the clocks showed slightly different times compared to those on the ground. They had moved into the future, by mere nanoseconds, yes, but enough to prove the point. Einstein also proposed that time is the fourth dimension of the universe. We live in a space-time continuum, where time is woven together with the three dimensions of space. This opens the door to theoretical time travel, at least into the future. But here's the big question, why can't we go back? There are many theories, but three main obstacles stand in the way. First, the second law of thermodynamics. According to this law, entropy, disorder, always increases. Eggs break, but they don't unbreak. Smoke spreads, but doesn't return to the fire. Everything flows toward chaos. Going back in time would mean reversing entropy, which defies one of the most fundamental laws of physics. In short, the universe resists going backward. Second, time paradoxes. Picture this. You travel to the past and prevent your grandparents from meeting. Then you're never born, and you can't go back to stop them. That's the famous grandfather paradox. The issue is causality. Every effect has a cause. If you break that chain, logic collapses. Some scientists try to solve this with ideas like alternate timelines or parallel universes, but there's no strong evidence. Third, no physical evidence. Neither quantum mechanics nor general relativity allow for matter or information to move to the past without breaking reality itself. And despite all our hopes, we found no signs of time tourists from the future. If time travel to the past were possible, wouldn't we have noticed? Still, science dares to dream. Some ideas sound wild, yet brilliant, like wormholes. According to relativity, shortcuts through space-time might exist. Physicist Kip Thorne proposed that, with exotic matter, wormholes could become stable, maybe even usable for time travel. But we haven't found any, and we're nowhere near the tech needed to build or control one. Then there's the idea of parallel universes. Some physicists suggest that changing the past wouldn't alter your present, only create a new timeline. In this multiverse, every decision spawns a new reality. Science fact or mathematical fiction? No one knows for sure. And some go even further, suggesting time might be an illusion. That only the present truly exists, and the past and future are mental constructs. If that's true, then there's no place to go back to, no timeline to travel along. So, what does science say today? As of now, time travel to the future is allowed, barely, and under extreme conditions. Traveling to the past, however, remains unreachable. But science has a history of breaking limits. Flying was once impossible. Talking across oceans was unthinkable. We went to the moon. Who's to say what we might discover in the next century? Time is more than a measurement. It's a dimension, an experience, a mystery. Maybe we'll never reverse it, but understanding it, that's already a remarkable journey. If you enjoy deep science topics explained clearly, like, subscribe, and hit the bell. This is Curio², where curiosity multiplies.